Hello everyone, welcome to my channel Chemistry with Mishal. So let's crack the concept of melting temperature trend. So because in the periodicity, the trend of melting temperature, this is very important, and students make mistakes solving while solving these questions about the melting temperature. They get confused because in our past papers we can see that many times the examiner has taken the question from the melting temperature, like which element has highest temperature in the period 2 and period 3. So what is the trend for melting temperature? Explain it on the basis of bonding and structure. So these are very common question in all the A level exams. So let's do this. Period 2 and period 3 elements, because for all the A level exams, period 2 and period 3 is included in your specification. Whole periodic table is not included in your specification. You just need to understand the period 2 and period 3 elements. So let's focus on this. As you can see, this is the elements. These are the elements from the period 2: lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. So I have been represented them as they are present in the nature. So lithium, beryllium, boron, carbon, nitrogen exist in the nature in the diatomic form, so I have represented it like this. Oxygen exists in the diatomic form, fluorine exists in the diatomic form, and neon exists in the monatomic form. So you can understand the whole concept of melting temperature, and you can you can deal any question, any tough question that your examiner can make about the melting temperature. You can do this by just understanding this concept. So you can see that melting temperature, they are giving you, first thing, you don't need to memorize the exact values of melting temperature. That's not included in your specification. You should just know their trend, and you should just know their bonding and structure, and you should just know the reason. So the lithium, it has a metallic structure. Beryllium, it has a metallic structure. So of course, if they have the metallic structure, so their bonding would be metallic bonding, and we know that metallic bonding is stronger bonding. So if you just compare the between the lithium and beryllium, if you just compare, sorry, if you just compare the lithium and beryllium, if you just compare the lithium and beryllium, lithium, it has metallic structure, beryllium has metallic structure, but beryllium melting temperature, it is higher than the lithium. So what is reason? Both have metallic structure, both have metallic bonding. So the reason is because lithium belongs to group 1, lithium can lose just one electron, but beryllium can lose plus 2 electron. So that's why their metallic bonding would be the stronger, because it has the two outer electron, so it can lose the two electron. It will have the more delocalized electrons, it will have the more delocalized electron, it will have the more electrostatic attraction between the positive two cations and electrons. So their metallic bonding is stronger than the lithium. So lithium has metallic bonding and structure, beryllium has metallic bonding and structure, but the beryllium has a higher melting point than the lithium, because it has a stronger metallic bonding for the two electron. So sometime your examiner can just ask you about the lithium and beryllium. So both are the metals, so why there is a difference? So you should know that because beryllium has a stronger metallic bonding, because it has the two outer electron, it can lose the two electron, it will get the positive two charge, positive, it will form positive two cation, there would be strong electrostatic attraction, the metallic bond would be stronger than lithium. So now next to go to the next element of period, this is a boron. Boron form the giant covalent structure. Boron is not a metal, it is a non-metal, but it is form a giant covalent structure because boron has 3 electron in the outermost shell. So it can form the 3 bonds, and it can form a giant covalent structure, and their network would be very strong. So its melting point is 2000. And then for the carbon, we know that we have studied organic chemistry, like we know that organic, there are millions of organic compounds made up of carbon. We know the concept of catenation. Carbon can make the 4 bonds, because carbon have 4 electron in the outermost shell, and carbon has ability to make the 4 bonds with the other carbon atom. So carbon can make the giant covalent structure. Word giant means the big covalent structure. We know that carbon exists in the form of the diamond, carbon exists in the form of graphite. This is, you can mention in your exam, in your answer, that carbon has a giant covalent structure like the diamond, like a graphite. So they involved their 3 electrons or 4 electrons in the bonding, so they have the very strong carbon carbon bond. So that's why they have the highest melting temperature across the period. So if you look at the second period element, carbon has highest melting temperature because carbon is an element which can use 4 valence electron in the bonding. So you should keep this in your mind that in the second period, which element has highest valency. So it is a carbon plus 4. Carbon can use its 4 electrons for making the covalent bond. Carbon can use the maximum electrons of their valence shell for making the bond. So that's why carbon make the giant covalent structures like diamond and graphite. It has a highest melting temperature. So when you are moving from carbon to nitrogen, let's look at their graph. You can see this is a graph for the second period element. This is a lithium 181, then beryllium, then boron, and then there is a carbon. So whenever your examiner is giving you the graph for the melting temperature and they can give you the peak, so you should know that at the peak, if they are giving you the graph for the second period, so you should be very sure that at the peak this would be the carbon, because the fourth group element would be at the peak for the second period. And for the third period, the fourth group elements which have the four electron in the outermost shell, they use all of its 4 electrons. So at your examiner can ask you that which element is at the peak, so it would be carbon in the second period. But after that, you can see that when there is a very huge decrease in ionization energy, like this is a very huge drop of melting temperature. Carbon has melting temperature 3550, but nitrogen has melting temperature minus 210. So what's happening here? Why there is a very huge difference? Because you can see that nitrogen exists in the nature in the form of N2. Nitrogen can form a covalent molecule. This is a very simple covalent molecule. Nitrogen never makes a giant structure. Now nitrogen can only form a covalent bond, the single covalent molecule. So that's why there is a very huge decrease in melting temperatures. And because as I tell all of my students that melting temperatures, they are also related to the intermolecular forces. So you can say that you can give the reason that nitrogen form the simple covalent molecule, and in this molecule they have the weak London forces, because nitrogen is a known metal and we know that known metals have weak London dispersion forces. So now we will come to the oxygen, then there is a fluorine, then there is neon. So you can see that their melting temperature are in minus. So melting temperature are decreasing after the carbon. So the trend is melting temperature across the period, it increases up to carbon, and after the carbon melting temperature decreases. Why? The reason is because they form the simple covalent molecule, and there is a weak London forces present between them. And for the neon, because it is a monatomic, so their force, it would be the very weakest London dispersion forces. You can look at the graph. You can see that at the carbon because of the giant covalent lattice. This is, you should know it, never forget this point. Highest at the carbon. Like some things in the periodicity, it should be on your fingertips. You don't need to think in your exam about what your examiner is asking. You should be very clear, and these things should be on your fingertips. The next thing is a huge drop from the carbon to nitrogen because structure change, because there is a very big structure change, giant to the simple molecular structure. So that's why it has been decreased. And also the difference between the nitrogen, oxygen and fluorine, this is not a very much difference in their decrease. Okay, so now look at the third period element. In the third period element, we have sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, and argon. So again, you can see that sodium is a metallic structure, metallic bonding. Magnesium has a metallic structure. Aluminium has a metallic structure. So in this three elements which exist are in the form of the metal, they have metallic bonding. Sodium has least melting point because sodium can lose just 1 electron, it can form the positive one. Magnesium can lose the 2 electron, it can form positive 2. And aluminium can lose 3 electron, it can form the positive 3. So you can say that the metallic bonding is strongest in the aluminium. So your examiner can also ask you that which element have the strongest metallic bonding in the period period 3, so your answer should be aluminium. If your examiner is asking you which element has strongest metallic bonding in period 2, your answer should be beryllium. So again, you can see that there is a silicon has a melting temperature 1414. It form a giant covalent structure because silicon and carbon, they are in the same family, they are in group 4 elements, they can form the 4 bonds. So silicon also form the giant covalent lattice. So in the period 3 element, highest melting temperature, it is again for the group 4 element silicon. So again, after the silicon, there is a phosphorus, there is a sulfur. So there is a big decrease in melting temperature because phosphorus, it exists as a simple covalent structure. Acid, it exists as a simple covalent structure. Chlorine, it has a simple covalent structure, and argon, it is a monoatomic. And we know that this is a simple covalent structure and they have the weak London dispersion forces. But there you can see there is an exception. Phosphorus to sulfur, there is a small increase in the melting temperature. So why it is? Because sulfur, it exists in the form of S8. So S8 molecule, because there are 8 atoms of sulfur, so this molecule, it is a greater larger in than the P4. So that's why its melting temperature is slightly higher than the phosphorus. So again, look at the graph. You can see they're from the lithium, from the sodium to magnesium, then aluminium, and then silicon. So whenever they are, your examiner is showing you the graph for the period 3, so you should be very sure that at the peak this would be the silicon, and there is a huge decrease in melting temperature from silicon to phosphorus exists in the form of nature P4. In the nature, it exists in the P4 form. Then there is a S8. P4 to S8, there is a slight increase in melting temperature because S8 has a bigger structure than P4, so its London forces would be bigger, stronger than P4. Then again there is a decrease because Cl2, and then there is argon. So let's look at the table. These points you can write it you can write it on the paper and keep memorizing it. Metallic bonding take place in lithium, beryllium, sodium, magnesium, aluminium. Giant covalent bonding is present in boron, carbon, and silicon. Simple covalent molecules are these, and monatomic molecules are neon and argon in the period 2 and 3 elements. And here these are the key ideas. Metallic elements, start of the period low to moderate temperature. Giant covalent elements like boron, carbon, and silicon, they have very highest melting temperature. And simple covalent molecules, they have low to melting temperature. And monatomic noble gases, they are extremely low melting temperature. Okay, so if all of the A level students, if you memorize these points, you should just know the trend of melting temperature, you should know the reason, you should know the bonding and structure in the molecule, and then you can attempt any question from melting temperature. Okay, thank you for watching my video.